Good morning, students. In continuation of our examples on the Fourier series for the second harmonics or the first harmonics, I mean the harmonic analysis, let me consider one more example. And the example is the following values of y and x are given, that is in the table. Find the Fourier series of y up to second harmonic. Refer this condition, this is the second harmonic. And in the table, the values of x and y are given simultaneously. For the given value of x, y will change. X equal to 0, it will be 9.0. For x equal to 2, y will be 18.2, like this. For x equal to 12, the y will be 9.0. Okay. Then, here just observe the condition of this table. How to analyze the table? It will be shown here, the values of y at x equal to 0, I mean the initial point, and x equal to 12, that is the end point, are given, that is in the table, and are same. Therefore, what happens here? For the value of x equal to 0, y will be 9.0. For x equal to 12, again it will be 9.0. Hence, the values are same. I mean the initial point and end points are same. Hence, the interval of x is what? From initial point to end point, that is 0 to 12. It is given under open interval. That is, the value of x is between 0 to 12. 0 is less than or is equal to x, is less than or is equal to 2. You can show the interval either in this form or in this form. Both are one and same. Both will give the same meaning. And we shall we shall omit the value of y. Why we need to omit the value of y? The word is very, very important here. Refer, this is an example of a circle. How we are going to implement the circle? The circle will be start from here, initial point. It will be cover and it will be meet again its initial point. That is what it connects both initial point and end point. Hence, it is a circle. Therefore, what happens here? We need to consider either the initial point or end point. Therefore, the explanation is given, we shall omit the value of y at x equal to 12. That is, we shall omit the end point of the given table, end point of the given intervals also. In the process of calculation, it is shown, the Fourier series of period 2L, because this is the arbitrary period. Therefore, the period 2L is given by, it's a known fact, y is equal to f of x, that is a0 by 2 summation n is equal to 1 to infinity an cos n pi x upon L plus summation n is equal to 1 to infinity bn sin n pi x upon L. This is general case, it is already known by you, and L is equal to 6. Why it is L is equal to 6? Because 2L is equal to 12. 2L. The period is 2L. This will be end point of the interval, that is 12. Therefore, if 2L is equal to 12, obviously L is equal to 6. L is equal to 6. It is shown here. Therefore, the Fourier series up to second harmonic, because the condition is given for second harmonic. This is given by y is equal to a0 by 2 plus a1. N is equal to 1 in this second and third term. a1 cos pi x upon 6 plus b1 sin pi x upon 6 plus a2 cos 2 pi x upon 6 plus b2 sin 2 pi x upon 6. Okay, therefore just observe here, since we are considering the value up to second harmonic, this is the very, very important fact. In the previous example, you might have seen the example for the first harmonic. And if it is possible, we shall go even with the third harmonic also. Therefore, here, if you put theta is equal to pi x upon 6, just there is no other meaning here. We want to consider the example in a simple manner. Therefore, we shall put that theta is equal to pi upon 6. Therefore, this expansion reduces to y is equal to a0 by 2 plus a1 cos theta plus b1 sin theta plus a2 cos 2 theta plus b2 sin 2 theta, where theta is equal to what? Pi x upon 6. Yes, my dear students, now we shall construct the practical harmonic analysis for the second harmonic. And for the previous condition, what happens here? Y is equal to a0 by 2. We shall numerically calculate the value of y a0. Then a1 cos theta plus b1 sin theta. Refer the second term. Therefore, cos theta is here, sin theta is here. a1 cos theta plus b1 sin theta. Next plus a2 cos 2 theta and b2 sin 2 theta. A2 cos 2 theta plus B2 sin 2 theta, and these results are needed here. Therefore, first we shall consider the construct the table with the numerical values. Here theta is equal to pi x upon 6. Therefore, if you put x equal to 0, theta will be 0. Then cos theta, it will be 1. Y cos theta, it will be 9. Cos 2 theta, this will be 1. Y cos 2 theta, 9.0, I mean 9. Sin theta, theta is equal to 0. Sin 0 is equal to 0. Y sin theta is 0. Sin 2 theta is 0. Y sin 2 theta is also 0. Refer the first row, and considering the second row using x equal to 2, y is equal to 18.2, and here theta is equal to pi upon 6. How much here? 60. Put x equal to 2, pi into 2 upon 6. How much here? Pi into 2 upon 6, pi upon 3. And pi upon 3 is 60 degree. Refer in terms of degree, 60 degree. Therefore, this term will be 0.5 because how it is 0.5? Cos 60 using the calculator. How much? 1 by 2. That is 0.5. Then 9.1. And cos 2 theta, this term will be minus 0.5. Next, y cos 2 theta, this term will be minus 9.1. And sin 2 theta, this term will be 0.86. And y sin 2 theta, 15.76. Sin 2 theta, this is the 0.86, and at the end y sin 2 theta, this term will be 15.76. Okay, refer the second row elements from the table, and while calculating these numerical values, take that care from your calculator that the term will be taken in terms of degrees, Okay, therefore now x equal to 4, the values will be 24.4 will be value of y, and theta is equal to pi x upon 6 will be 120. Then minus 0.5, next minus 12.2, next minus 0.5, next minus 12.2, next 0.86, okay, next 21.13, next minus 0.8, and at the end minus 21.13, minus 21.13. These are the elements taken when x equal to 4. Similarly, for x equal to 6, y will be 27.8, it is already given, and theta will be 180. Next minus 1, next minus 27.8, next 1, next 27.8, and sin theta will be 0, 0, 0 and 0. Okay, therefore next when x equal to 8, the respective values of y will be 27.5, which is already known, and theta will be 240 degree. X equal to 8, what happens here? Pi into 8 upon 6. This will be 240. Calculate from your calculator. Use the degree mode while calculating the numerical values. Minus 0.5, next minus 13.75, next minus 0.5, next minus 13.75, next minus 0.8, next minus 28.81, minus 28.81, and here 0.8, next 28.81. Do not take the values directly without any calculation. Do the calculation of your own using the degree mode from your calculator. When x equal to 10, y will be 22.0 and theta will be 300 degree, and for cos theta 0.5, for y cos 2 theta, this will be 11, next will be minus 0.5, next will be minus 11.0, next will be minus 0.8, next will be minus 19.05, next will be minus 0.8, next will be at the end minus 19.05. Okay, this is the table we need from the construction of y is equal to a naught by 2 plus and so on for the second harmonic. The respective summation, I mean the total values are given by summation of y is equal to addition of all these results 128.9. Next, y cos theta. Y cos theta will be minus 24.65. Next, y cos 2 theta, its summation will be minus 9.25. Next, y sin theta, this will be minus 0.59 and at the end minus 0.6. These are the respective numerical values which we need to take for calculating the second harmonics at the end, and the values of second harmonics are a naught is equal to what? 2 upon n summation y. 2 upon n summation y. What is the value of n? The values of x are given here 1, 2, 3, 4, 5, 6. Therefore, the values of x are 6 in number. Therefore, this term is equal to 2 upon 6 and the summation of y. What is the summation of y from the table? It will be 128.9. Therefore, this is 128.9 and after calculation, the value will be 42.967. It reduces to 42.967. Similarly, A1. A1 is equal to what? Therefore, this is 2 upon n summation y cos theta. Putting the values of again n is equal to 6, summation y cos theta is minus 24.65 just over here. Therefore, this term is equal to what? Minus 8.217. Similarly, A2. A2 will be what? This is 2 upon n summation y cos 2 theta. This term is equal to minus 3.08. And B1 will be 2 upon n summation y sin theta, and this term will be minus 1.9918. And B2 will be 2 upon n summation y sin 2 theta. This term will be minus 0.202. And you just observe here, my dear students, we have taken the values up to second harmonic. Hence, cos 2 theta is given, sin 2 theta is given. If it is a first harmonic, it will be end up only with cos theta here, sin theta here. If it is continued up to the third harmonic, suppose the example is given. Actually, your syllabus is restricted only for the second harmonic only. That's why I am not taking any third harmonic example. The A0, A1, A2, B1, B2 are already, the formula is given. In the examination also, you need to write the respective formula, the relevant formula. Just observe here. It's a relevant formula and substituting the values from this table. Therefore, the second harmonics y is equal to, it is given by f of x is equal to, what is A0 by 2? A0 by 2 is 21.4835 plus, what is the first term? A1 cos theta. This is minus 8.217 cos pi x upon 6. Next, minus 1.9918 sin pi x upon 6. You just observe here, I have taken from the formula before given, before this table. Okay. Therefore, plus A2 cos 2 theta. A2 will be what? Minus 3.083 cos pi x upon 3 minus 0.202 sin pi x upon 3. Okay, A1, A2, A1, A2, B1, B2 are, they are calculated here. They have been substituted. The value of A0, actually the first term is what? A0 by 2. Hence, 42.967 divided by 2. How much it is? 21.4835. This is the second harmonic. This is the second harmonic. Okay. Therefore, my dear students, without a calculator, do not go for any calculation. In the examination also, the calculator is taken directly. Do not use your mobile to calculate the things, though the mobile is also useful to calculate all these things. In the examination also, do not carry your mobile. It is only the scientific calculator is allowed without any function. Therefore, this is the way of finding the second harmonic for the table. Okay, thank you.